So we have one more thing we can look at when it comes to implicit differentiation, and that is taking a second derivative. Okay. So the process is really the same. You need to start by taking a first derivative. So we will take the first derivative here. When I take the derivative of a y term, I multiply by dy dx. I'm going to solve for dy dx, which means I'm just going to move the non-term over and divide. So should I simplify? What's the answer to that question? Yes. So there's my first derivative. Now I'm going to implicitly differentiate this again. So when I take the derivative of dy dx, I get d2 at d2y dx2. Remember, that's that funky notation for the second derivative. And then now I'm going to take the derivative of negative x over y, which means I'm going to need a quotient rule. So low d high minus high d low all over low low. Okay, now where that dy dx is, I'm going to actually substitute in. I know what dy dx is equal to. It's negative x over y. So I'm going to sub in and now it's time to simplify. So I have a complex fraction here, a fraction within a fraction. I usually just address that by multiplying the top and the bottom by that common denominator. So I'll distribute the y on the top. It will cancel the y in the denominator. So I just have negative y squared minus x squared. Now, a lot of times there's a trick to these where look at what our original equation was. It was x squared plus y squared. X squared plus y squared is 25 in this problem because that's the equation we're working with. You'll notice if you factor a negative out of the top, what does the numerator become? Negative, but then y squared plus x squared. So we're going to make one last substitution to simplify that expression further. Oops. I was trying to erase. I'm still trying to erase. Okay, so this substitution here comes from the original equation, which tells us that x squared plus y squared equals 25. And that's a second derivative using implicit differentiation.